technological change, technological development, technological achievement, or technological progress is the overall process of invention, innovation and diffusion of technology or processes. In essence, technological change is the invention of technologies and the commercialization via research and development, the continual improvement of technologies, and the diffusion of technologies throughout industry or society. In short, technological change is based on both better and more technology. Modeling technological change. In its earlier days, technological change was illustrated with the linear model of innovation, which has now been largely discarded to be replaced with a model of technological change that involves innovation at all stages of research, development, diffusion and use. When spoken about modeling technological change, often the process of innovation is meant. This process of continuous improvement is often modeled as a curve depicting decreasing costs over time. TC is often modeled using a learning curve, x cort equals CO asterisk xt caret b. TC itself is often included in other models and was often taken as an exogenous factor. These days TC is more often included as an endogenous factor. This means that it is taken as something you can influence. It is generally accepted that policy can influence the speed and direction of TC. This is referred to as induced technological change. Invention, the creation of something new, or a breakthrough technology. For example, a personal computer. Diffusion, the spread of a technology through a society or industry. The diffusion of a technology generally follows an S-shaped curve as early versions of technology are rather unsuccessful, followed by a period of successful innovation with high levels of adoption, and finally a dropping off in adoption as a technology reaches its maximum potential in a market. In the case of a personal computer, it has made way beyond homes and into business settings, such as office workstations and server machines to host websites. For mathematical treatment of diffusion, see logistic function. For examples of diffusion of technologies, see diffusion of innovations. International Institute for Applied Systems Analysis for assorted diffusion curves such as appliances, household electrification and communications. See diffusion of innovations. Diffusion data. Technological change as a social process. Underpinning the idea of technological change as a social process is general agreement on the importance of social context and communication. According to this model, technological change is seen as a social process involving producers and adopters and others who are profoundly affected by cultural setting, political institutions and marketing strategies. In free market economies, the maximization of profits is a powerful driver of technological change. Generally, only those technologies are developed and reach the market that promise to maximize profits for the owners of incoming producing capital. Any technologies that fail to meet this criterion, even though they may satisfy very important societal needs, are not developed. Therefore, technological change is a social process strongly biased by the financial interests of capital. There are currently no well-established democratic processes, such as voting on the social or environmental desirability of a new technology prior to development and marketing, that would allow average citizens to direct the course of technological change. Elements of diffusion. Emphasis has been on 4 key elements of the technological change process. An innovative technology communicated through certain channels to members of a social system who adopt it over a period of time. These elements are derived from Everett M. Rogers' diffusion of innovations theory using a communications-type approach. Innovation. Rogers proposes that there are 5 main attributes of innovative technologies which influence acceptance, which he calls the ACCTO criteria. These are relative advantage, compatibility, complexity, trialability, and observability. Relative advantage may be economic or non-economic, and is the degree to which an innovation is seen as superior to prior innovations fulfilling the same needs. It is positively related to acceptance. Compatibility is the degree to which an innovation appears consistent with existing values, past experiences, habits and needs to the potential adopter. A low level of compatibility will slow acceptance. Complexity is the degree to which an innovation appears difficult to understand and use. The more complex an innovation, the slower its acceptance. Trialability is the perceived degree to which an innovation may be tried on a limited basis, and is positively related to acceptance. Trialability can accelerate acceptance because small-scale testing reduces risk. Observability is the perceived degree to which results of innovating are visible to others and is positively related to acceptance. Communication channels. Communication channels are the means by which a source conveys a message to a receiver. Information may be exchanged through two fundamentally different, yet complementary, channels of communication. Awareness is more often obtained through the mass media, while uncertainty reduction that leads to acceptance mostly results from face-to-face communication. Social system. The social system provides a medium through which and boundaries within which innovation is adopted. The structure of the social system affects technological change in several ways. Social norms, opinion leaders, change agents, government and the consequences of innovations are all involved. Also involved a cultural setting, nature of political institutions, laws, policies and administrative structures. Time enters into the acceptance process in many ways. The time dimension relates to the innovativeness of an individual or other adopter, which is the relative earliness or lateness with which an innovation is adopted. Economics. In economics, technological change is a change in the set of feasible production possibilities. A technological innovation is Hicks neutral, following John Hicks. If a change in technology does not change the ratio of capital's marginal product to labor's marginal product for a given capital to labor ratio, a technological innovation is Harrod neutral if the technology is labor augmenting. It is Solow neutral if the technology is capital augmenting.